Hello, and welcome to this video lesson in discrete structures. We're in the logic unit, and we're talking about how to set up the inputs for a truth table. We're going to use 0 for false and 1 for true. Now, some books use a T for true and an F for false, which kind of makes sense, but this book leans more towards the engineering end of it, where zeros are false and ones are true. The other thing that happens is for everything I show in this video, every time I start with a 0, if you use the true-false version of it, it tends to start with the true instead of the false. So your engineering classes will do it more like this, with the zeros and the ones. The engineering class I took in digital systems and digital systems design, those classes use zeros and ones, and I believe our truth tables were set up like this. Now, the question for a truth table is always, how many rows do I need? And then what order do I put the inputs in? We all have to have a uniform way of doing that so we can compare our answers easily. And you have to do it uniformly from problem to problem in case you're looking for things like equivalence. So let me go through that and how do we set these up. This tends to be a real sticking point for students unless I'm very careful about explaining it. So the first thing you do, let me get a different color pen here to write with. The first thing you do, it's only slightly different, is calculate the number of rows required. If your statement says P and not Q, there are two statements there, two different statements, a P and a Q. You count how many different letters there are. And it's always going to be the number 2 because each of these can be either true or false to n, where n is the number of statements. Okay? So that's how you figure out. So this will be 4 rows if there's 2 statements. So 2 statements gives you 4 rows. 3 statements gives you 8 rows. 4 statements gives you 16 rows. 5 statements gives you 13 rows. If you were doing a digital circuit design, the statements would be inputs. If you had 5 different inputs, you'd need 32 rows to do your truth table. And then you do some sort of a Carnot map or something that we won't get into to create your circuit. I loved this class in digital systems and digital systems design when I took it. It had a lab with it. We had to make toll booths and tell if people put enough money in or not. It was fascinating. It was one of my top choices for what to go into after I graduated as far as a job. I said either electromagnetics or digital systems, and I got a really good job in electromagnetic interference engineering. That's where I went, but I loved these classes. So hopefully my enthusiasm comes through. So the first thing you do is have to figure out how many rows you make. Then you have to put the statements in alphabetical order. Notice I put P first and then Q here. P and then Q. If I had A, B, C, I would put A, B, C. If I had X, Y, Z, I would put X, Y, Z. We tend to use P, Q, R, and S in logic. No particular reason. I could have F, G, H, I, but you will go left to right with the inputs. Now, if I had F, G, H, I, that would be 4 statements. And 4 statements will be 2 to the 4th rows. I would need 16 rows. I am not, except maybe in one homework problem, I am not going to make you do a test question with 16 rows. I don't want to grade that, to be honest with you. Maybe 8, though. So if you had 3 statements, you'd have 8 rows. And here we see an example where you have 2 statements, P, Q. Here are your 4 rows. There's row 1, row 2, row 3, row 4. Okay, this is what I mean by rows. And you always, always, always start below the variable in the left column. You have 4 rows. Half of 4 is 2. Fill half with 0, so 1, 2 zeros, and then 1, 2 ones. And then you can see, okay, you've got half of zeros, half of ones. The next column over, so P is 0, Q can be either 0 or Q can be 1. This comes from the probability tree where if you pick P is 0, now Q can be either 0 or 1. If we follow the paths, we're gonna end up writing the paths across in a row basically. Now if P is 1, Q can either be a 0 or a 1. So here's the path 1, 0. Here's the path 1, 1. You always start with the zeros. So this is why we have 4 statements, because there's 2 choices for P, and no matter what I choose for P, I still have 2 choices for Q, 1, 2, 3, 4. Now when I do 8 statements, I'm going to do something similar, only there's going to be more stuff, obviously. I said there's 8. So I have P, I have Q, and I have R. The possibility tree, or the paths, the way you can draw all the paths, is this. You still only have 2 choices for P. It's a 0 or 1. Now, Q, you can have as a 0 or 1. There's one path. And even if P starts out as a 1, Q can be a 0 or a 1. And then, no matter what Q or P was, R still has its choice of being a 0 or a 1. Notice I'm always starting the 0 first. I said the word 0 and I couldn't write a 1. 0, 1, 0, 1. All right, let me fix that bad looking 1. All right, so that's a 1 there. 0, 1, 0, 1. Now, if you look, the first row is this top path. I go from, let me pick another pen. Top path, I go 0. I didn't pick another pen, sorry. There we go. I really picked it this time. 0, 0, 0 is this path here. And then another path. Oh, we'll pick that. The next path is 0, 0, 1. See that? So this path is your 0, 0, 1. That's where these come from. Now, you don't have to draw this tree every time. You just have to follow this patterning. When I have 3 statements, I know I have 2. Oh, I thought I picked a new pen, and I didn't. And I hang there for a little longer, I guess. There we go. 2 to the 3rd is 8 rows. So half of 8 will be 4. So you see right here, top 4 rows are zeros. Then what happens in this next part is, oh, I didn't draw that first one right. There's your top 4 rows. And then in Q, half of the 4 is 0. So you have 2 zeros, then 2 ones, but you're not done with the table, so you repeat the pattern again. 2 zeros, 2 ones. So if you have 4, then 4, the next column goes 2 zeros, then 2 ones, 2 zeros, and 2 ones until you're done. And then half of these 2 zeros is 1 0. You can then do 0, 1, 0, 1. That last row, last column, I say row, I should be saying column, will always alternate. So what you have here, I'm going to erase this. Here we go. So the top half is zeros. You have 4 zeros. Then Q is 2 zeros, then 2 ones, 2 zeros, and 2 ones. And R is 1 0, 1 1, 1 0, 1 1 until you are done. The top row will always be full of zeros. The bottom row will always be full of ones. The last column will always alternate. And it comes from this possibility tree, if you can follow along with that logic. You don't have to remember that. You just have to remember, calculate the number of rows, put your variables in alphabetical order. If I put R first and then P, so let's say I had made this an R. I'm sorry, I still have the eraser picked up. If I had made this an R and this a P, I would have still covered all of the possible inputs, but my order would be different than the order of somebody else who might be doing the same thing or doing a different statement. What if I want to do 2 statements and compare them? If I do one in this order and one in a different order, I can't compare the output columns to see if they're the same because the inputs are set up in a different order. So you don't want to do that. You want to always have it in alphabetical order. This needs to be a P, and this the Q, and then the R, or A, D, F. I don't care what the letters are. They have to go in alphabetical order, left to right, in order for me to grade that correctly. Is it possible to, draw conclusions, especially when you get into arguments with other orders? Yes, but don't mess around with it. Pick a way and do it. And I'm picking the way for you. That makes it even easier. A little sarcasm there. Sorry about that. But so then for 4 statements, as you can see below, I've got 16 rows. Here's the 4 statement setup. So if you go down to this row here, there's 8 above and 8 below. And then here, you notice you have 4 zeros, 4 zeros, 4 more zeros, 4 more, 4 zeros, 4 ones, 4 zeros, 4 ones. And then half of 4 is 2. You got 2 zeros, 2 ones, 2 zeros, 2 ones until you get all the way to the bottom. And then half of those are zeros and ones. And that goes along with our possibility tree. You can see you would have, if I added another variable to my tree up here, if I added the variable s to this tree, each of these would come off in a 0 and a 1. And I would suddenly have twice as many as 8, which would be 16. So that is how you set up the inputs. And first thing you have to determine is how many rows does your problem require. I might not be doing this entirely right, but you get the idea. How many rows does your input require? And that's determined by the number of different statements there are in your problem. So you just count how many different letters. It doesn't matter if you have, like if you have P and not Q, if then P, this is still 2 statements because the only letters that appear are P and Q. It doesn't matter that you used a not Q. And I used the other symbol for not. Your book uses this symbol. This is also a symbol for not. You may see that here and there. So what I should have written was P and not Q. And the book I used to teach this course from, and the book I'm teaching this unit in another course this semester, uses the other language, and it uses trues and falses. So I'm hoping to keep this straight. So this is the not Q. But there's a P, there's a Q. Oh, that's another P. Even if this were a not P, I would still have 2 statements, P and Q. That would not be 3 statements. So there would be 4 rows in that truth table. I'm going to do another video that does some truth tables. You'll want to tune into that one. I hope you found this helpful. Email me your questions, and I'll see you in class.